Currently, there are 6 hardest problems in science. There were 7, but in 2010, a Russian guy, solved one of the problems, and now there are 6 hardest problems in science. If anyone solves those problems, or one of those problems carries a price of $1 million US. So if you are like an academician, a professor at the university, you are a student in science, you are learning, okay? Take it very seriously. To study whatever you are studying, take it very, very seriously, okay? So that you may be able to understand some of the hypotheses that are developed, especially in science. And most of these hypotheses, they deal with mathematical problems, which are cross-cutting across many other fields and industries as well, many other sectors. They apply. So 7 toughest or hardest problems in science, and one of them was solved by a crazy Russian guy. He solved it and he was awarded $1 million US, but he rejected the prize because of another problem. He said that part of his solution was like copyright, was copied from, he lifted from another guy. So he said that because of that, I cannot receive that money alone, okay? If the money was offered to me, it had also to be offered to the previous guy who developed a foundation from which I picked my hypothesis to solve that problem. So, okay, let me just say 7 hardest problem, 1 solved. Okay, so I will read them out, all of them, so that you can understand. You can get what they are. The first problem, the one that was solved, is called Poincaré conjecture. It was solved in 2010, like I said. Poincaré conjecture in mathematics, solved in 2010. Let me just browse through. Maybe I can get how to explain about Poincaré. Okay, let me before I explain what they are, let me just go through them. The second one is called Birch and Swinnerton Dyer conjecture. That's the second one. Birch and Swinnerton Dyer conjecture. The third one is called Hodge conjecture. Hodge conjecture. The fourth one is called Navier stroke existence and smoothness conjecture. The fifth one is called P versus NP philosophy conjecture. Philosophical science of philosophy. The sixth one is called Riemann hypothesis conjecture. Riemann hypothesis conjecture. The seventh one is called Young-Mills existence gap, mass gap conjecture. Young-Mills existence mass gap conjecture. Right? They are 7, but one was solved. But even if it's solved, it doesn't mean that you can't come up with a different solution. You can still attempt it, or even to prove it, because by awarding $1 million to that Russian, it means that his proposal for the solution of this conjecture was tested rigorously and found that it was solving that conjecture, solving that problem. Okay, it was solving that problem. When you say conjecture, for example, what do we mean by conjecture? Conjecture is like a theorem, okay, where a scientist discovers a theorem, mathematical theorem, okay, that tends to describe a certain condition. Okay, so this is all mathematical. So they come up with an equation or a principle, like we have said already here, or a hypothesis. And that hypothesis is in the form of an equation, okay, but that describes certain conditions. All right. So he tends to question, okay, that let me maybe if I can give you example. Let me give you example of Riemann hypothesis, okay. Riemann hypothesis is the one that personally I understand it very easily. It's number 6. With the Riemann hypothesis, okay, this Riemann, he came up with the equation that describes existence, okay. So he said, based on this hypothesis, integers, okay, representing existence, okay, solid existence, and then trivial zero, non-zero, right? We will discuss later what they stand for. But he said, given this equation that goes like this, like this, like this, okay, it means in the universe, okay, there should have been many types of intelligent life. Given this equation, okay, there should have been many intelligent life, not only humans on Earth. Even in Mars, there should have been people. There should have been humans. There should have been animals, all right? Even in Jupiter, right? Even maybe in Saturn, in Uranus, or wherever, all the planets, okay, in the universe, wherever, there should have been many intelligent life forms, okay? So he is asking, where are aliens? If that is the case, where are aliens? By now, we should have been visited by aliens, or we should have picked up signals of the aliens. But the truth is that we have not picked up any signal. Why is that the case? Okay, so this equation needs someone who can solve it. Okay, should bring something that can solve this equation to explain why. Not explaining why by philosophically that is suggesting or discussing. No, what you need is to plot an equation, okay, that will solve those inconsistencies. Why we are not yet visited by aliens? Why there is no intelligent life elsewhere in the universe, only on Earth? Okay? So that one is called Riemann hypothesis. It's number 6. So I had to use this example because it's something that personally I understand it easily. But it's a mathematical equation. Okay? It's a mathematical equation. You can solve it, and then you come up with a philosophy to say, why is this the case? This is the case because of this. And it must be in uniform to what Riemann plotted. So that's the problem. So these conjectures, my point here is that these are conjectures. These conjectures have a prize money of $1 million US. Okay. $1 million US. Any person in there, any scientist who will solve this hypothesis will receive $1 million US. Any one of them. Okay. Any one of them. Like I say, breach and swimmerton, okay, dire conjecture. Breach and swimmerton, dire conjecture. Let me just browse through to explain to you what it is. bridge and sumaton conjecture, one of the most challenging mathematical problems in science. Okay? As you know that mathematics and science, they are related. You can't discuss science without applying mathematics. Of course, some scientists argue, or some physicists argue, that science is not mathematics, mathematics is not science. But there is a close relationship, because you cannot describe equations. When you use mathematics, okay, they become universally acceptable, universally communicable, universally. That's why a theory has to have a mathematical equation so that you can easily interpret it. Okay. But it's not easy to plot a mathematical equation. It's very difficult. You have to use sets of symbols to represent conditions that we're talking about. Simply mathematics. So this bridge and sumaton, which is number 2, I will not discuss number 1. I'll just go to number 2. This deals with, it describes the set of rational solutions to equations defining an elliptic curve. An elliptic curve, and it still remains an open problem. There is a physical condition associated with this, okay? But mathematically we are just saying it's a set of rational solutions to equations that define an elliptic curve. Okay? So it's a conjecture because there is a problem. When we say a conjecture, it means that there is a problem. Okay? It means that the nature of that equation and the reality do not seem to agree. The equation is talking about this. For example, just to give an example, in science, in physics or in science, if you take a glass, okay, and throw it will break. Okay? The glass will break. The laws of science say that it should have been possible to bring back the glass, to unbreak it. The laws of science say that it was supposed to be possible. But why is it not possible? When you break the glass, you can't unbreak it. That is a conjecture. See, that is a conjecture. So this bridge and sumaton is just one of the equations that is similar to that. It's a conjecture, but this describes rational numbers, a set of numbers on elliptic curve. Thank you so much. So then we have Navier-Stokes existence and smoothness. This one deals with the smoothness of liquids and fluids, the calculation of fluids, that at this given condition the fluids were supposed to be like this. At these given conditions the fluids were supposed to be flowing or not flowing. But why do they flow? It's something like that. Alright. So then there is number 3. It's called Hodge conjecture. Hodge conjecture. Hodge conjecture is another type of conjectures where, so let me just try it out what Hodge conjecture is about. I'll explain to you what it is. Hodge conjecture. Okay, Hodge conjecture. Okay, Hodge conjecture is a calculus problem as well. Hodge conjecture is a calculus problem. The solutions they find in the calculus and the reality, okay, don't seem to agree, like I said before. Okay. But you can get most of these things, you can get them all of them in details. If you want to know about this, you can read books like let's check. Okay, you can read Millennium Science Prize Problems, or the hardest problems that have $1 million US prize award. Okay, so from there you get to understand every problem. They explain every problem, but it's very mathematical, so you have to be good in mathematics. So there is P versus NP. Okay, this is about computer science. It talks about computer science, electronics, okay, mathematical logic, philosophy, cryptocracy, all right? It's about AI, all right? Artificial intelligence is about computer. This is about computer logic, how computers work, and so on. There is a philosophical question that doesn't make sense. It's a conjecture. It doesn't make sense in mathematics, all right? So that's number 5, right? Then the last one, the Riemann hypothesis, which I just explained. So anyone who can solve these problems will get $1 million US. Any of these problems. Okay, how do you get the money? 1 million. How do you get the money? Okay, like let's go to number 1, Poincaré conjecture, which was solved in 2010. What this guy did, the guy who solved this one, what he did was he solved the problem. After he solved it, okay, then he registered his solution, right? Registered his solution and patented it, right? That it belongs to him. But then he published it in the magazine or online. Some say he published it in the websites or in the groups, online groups of science, right? And he proposed it to the forums of science. Okay. Once you do that, all right, they take the proposal of the science groups, then they observe it. So far, they've said there are hundreds, thousands of solutions to these problems, but when they compare them, or when they check them, they find that they don't solve that problem. They don't solve the problem, right? They don't solve. So your equation must actually explain in reality the solution to that condition, right? That the conjecture poses. So that's it. Other problems that attract awards in science, for example, even singularity. If someone can solve the conjecture of singularity, can receive an award. What is a singularity problem? A singularity problem is that, like in the Big Bang, okay, the best model in science, which is called Big Bang theory. All right, Big Bang theory explains the birth of the universe, where the universe came from, right? Is based on evidences, okay, like inflation and the cosmic microwave background, right? So if the universe, and they discovered that the universe expanded, so when they rewind it, when they rewind it going back, they find that the universe must have been a single atom somewhere, because it's been expanding. It might have been a single atom somewhere in time. So the problem is that if it was an atom, if there was one atom, there are two questions that should happen. The first question is, where did it get, or where does it get the energy to expand? Okay, that's the first question. The second question, if it was an atom, if a singularity was an atom, okay, where did it come from? That's the question. If it was an atom, yes, okay. How was it? Where was it? How was it get born? Where did it come? Where did it originate from? That atom, the atom that had everything inside it to expand and become everything that we see as the universe. Okay, and by the way, this is where our new model in science, which we call decay model, comes in. Please support our model. We are coming in. Please subscribe, and you can check us online. We're everywhere now. We are building the forums. We are building the web pages where you will get our model, which we say decay model. Okay, decay model in science. All right. So this is a new model that's developed in Africa, and it's talking about Big Bang theory is there inside them. It's incorporated, and also it's going as far as pre-existence. Okay, decay theory is the only theory that is talking about pre-existence. What was pre-existence? Okay, so it's one way of trying to solve this problem, but we will make it a proposal, official proposal to the authorities and the forums of science. What decay theory can solve. All right. So the other problems that you can get, like in science, that can attract prizes, apart from the decay theory, is the unification of quantum theory. As we say, the best theories in science, and relativity, okay, general relativity and special relativity of Albert Einstein and Isaac Newton, and so on and so forth. So unification of general, let's just say general relativity and quantum theory. General relativity is the best model so far when it comes to classical, okay, mechanics, where it talks about large bodies, okay, gravitationally how large bodies operate, like planets, okay, how they operate, okay. It's one of the best that has been tested and found that is accurate. But still, I personally am arguing on my part that no matter, even if these models are arguing, they are only interpretations of the reality. But they may not be the reality. They are only interpretations. They are interpreting the reality. Albert Einstein, Isaac Newton only interpreted the reality. It's the same like solving mathematical problem. You can use so many, ways to solve a single problem. Okay, you can wind around, but still you solve that problem. You can enjoy solving that problem using your own hypothesis, those on our ideas that can solve the problem, the mathematical problem, but you still arrive at the same answer. So, unification. So when it comes to quantum is the best theory that describes subatomic level. At subatomic level, at the best subatomic level, how the universe works. Okay? You have to use quantum theory. Okay, it's the one that is very good. And if you go further, deeper, you include quantum field theory. Okay, so you will use quantum field theory to understand the universe, how the universe works. Quantum field theory. Right. So, if you can come up with a solution that you can unite, or if you can come up with a model of model in physics that can explain, that can cross-cut quantum and the relativity, and be able to explain the universe, large bodies and subatomic systems, okay, you will likely get a prize money, because this is the big problem in science that is still not solved. So there are many theories that are trying to solve, like for example quantum. We have heard about quantum, loop quantum gravity, and there is what we call string theory, okay, that is trying to solve the same problem of quantum. The conjecture of quantum and the relativity. So they are trying to solve. And unfortunately, and now we're hearing of cyclic universe. Okay, but unfortunately, these theories, okay, they are found to contain other problems as well. Like for example, string theory. For it to work, it must involve over 50 dimensions, 26 dimensions. They say 26 dimensions. Others are interpreting you must have over 30, even 50 dimensions in the universe. But the reality must be no dimensions. Okay? The basic dimensions must not be like now we know dimensions, there are only 3. And the scientific dimension is the additional one, space-time, which we are arguing in the debate theory. And we'll let you know what are our arguments about the 4th dimension, which is space-time. And we are saying that it's indeed true that space and time are not one. So we argue that, but we will discuss about this. But then 4 dimensions, okay, plus others, basic ones, they must be 10, okay, even 11, okay, and more others up to 26, and furthermore up to 50, more than 50 dimensions in existence. That's straightforward. And the universe, there must be multiverse. That the universe must not be one, there must be many universes. So this is confusion. That's why people